Hi there guys, today we're going to have a look at arithmetic series or arithmetic series and sequences. So let's get stuck in. So as soon as we change it to a series, instead of putting commas in between the terms, we're actually going to be putting pluses. So that's a series. So an arithmetic sequence is when there isn't the pluses. So this is one, for example. This is another one. And you can see this first one, it going up in 2s, and the second one is going down in 3s. You could also have something more algebraic like this, and you can see that the difference in the second one is plus d, then we're adding on 2d's, then adding on 3d's. So basically arithmetic means you're adding on the same each time, adding on a constant each time. To look at this one, it's d plus 2d plus 3d. If you think about here, the first one is plus 2, so that d is 2. Then 2d's would be 4, so to go from the first to the third, it would be 2d's, or 4. And then 6, which would be 3 times the difference. And that's just written in an algebraic form. Okay, so that's basically what we mean. So arithmetic series can be written in this form. So if a is the first term, and the d is the difference. So then it can keep going and going and going and going until we get to the nth term. So if you think about the nth term, it's quite easy to work out. Because how many d's are here? Well, that's one less than the number of terms. How many d's are here? Again, one less than the number of terms. So if I said the nth term, well, how many d's would you need for the nth term? Well, it would be one less than the number you're actually looking for. So we actually say the nth term of any arithmetic series is this. So the number of d's you need is one less than the number term you're looking at. So the 18th term, for example, would be a plus 17d. So make a note of that, that's really important. And this is what we're going to be using now as our nth term formula to solve all our problems. Okay, so here we have an arithmetic series. You can see that the pluses are now there instead of the commas. It goes on. We're not telling you when we're stopping. We're just saying it goes on and on and on with these 3 dots. So what's the 20th one? So here we go, our nth term. Want to find the 20th one? Our n's going to be 20. So a is 5, remember, and d, you should be able to see, is positive 3. So u20 is 5 plus 1 less than 20, 19, lots of the difference, which is 3. Bid mass, 62. Easy peasy. So again, 50, 5 plus 1 less than 50, times 3. Again, a bid mass problem, just do it in your head, or short multiplication, long multiplication, whatever you call it. And there you go, easy peasy. That's exactly the same, but you'll see the difference is going down in 4s. So write your formula, don't ever skip this stage. Your a is 28, the d is minus 4. So 28 plus 9 lots of minus 4. Bid mass problem, just be careful. 28 take away 36 is minus 8. Write it down, pop the 30 in for each of these values of n, do your bid mass, and minus 88. Now you think 30th term along, it is going to go into the negatives, it is going to be quite small, so you can double check just using a bit of logic too. Okay, so here you can see we've decided to end the series, but this time we want to know the number of terms. So we know it starts at 6, that's a, we know the difference is 4, we know we're stopping at 122, just how many numbers were there? So here's 1, 2, 3, 4, but what number is the 122nd? Well, sorry, what number gives us 122? So here's our formula. A is 6, let's pop that in. We don't know what n is, so we're stuck here, but we know it's going up in 4s. Now here we have a bracket times by a constant value, so normally what we do is put that in the front. I haven't done that here, but it's 4 lots of that bracket, so I'm hoping you're okay with following that. Tidy this up, so you've got 6 plus 4n, take away 4. So 6 plus negative 4 is take away 4. If the bracket's there, you shouldn't make a mistake. There you go. So that's the nth term. Now, Find the number of terms. Here we have the nth term, and we know 122 is in there. So if we put 122 equal to this nth term, we can find what value of n gives us 122. And that's just a matter of solving the equation, dividing by 4, and so it's the 30th one along. Okay, again, exactly the same. So let's write our formula. A is 40, pop that in. We don't know n, but we know this time it's coming down in nines. So what I have done here, I've put this in front of the bracket, but what I don't know why I've done this. This plus, I wouldn't even bother with it, because that's going to be a minus 9 in front, so it changes. So please ignore that plus. Let's pretend it's not there. So you've got 40 minus 9n's, and this is the trickier bit. So you've got a minus 9 multiplied by a minus 1. So that's plus 9. So the negatives is where it's going to catch you at. Okay, so I don't know if you noticed, but if you actually look at these numbers, it's going down in nines. What else goes down in nines? Your minus 9 times table. And you've got a plus 49 to minus 9 to get 40. That was the same on the other one. I want you to get used to using this formula, but it's just another way of checking that you've got your nth term right. So what number of term gave us minus 176? Let's put it equal to that. Let's take away 49. Let's divide by minus 9, and you get 25. Okay. So this one's a great example because they're putting it in there to really confuse you. You should notice that they all have an x, so let's just ignore the fact there's an x and do it as the numbers suggest. So let's just look at 2, 5, 8 and 11. Write a formula down, which I haven't done. That's very naughty of me, but write your formula down. A is 2, and the difference here is 3. Let's expand this, so 3 lots of that bracket. I don't know why I'm doing this, but it's 3 lots of that bracket. Oh, here you go. So just ignore that middle line. That's absolute rubbish. So you can expand it. So 3n minus 3. Tidy it up, and you get 3n minus 1. Again, 2, 5, 8, 11. That's going up in 3s. So does the 3 times table. It's not your 3 times table. It's 1 less. So you can get there straight away without doing this. But this formula, I promise you, it will come in handy later. Okay, so because it's just a 3n minus 1, but then an x, so we put it in brackets, that's the numbers part, that's getting us to 2, 5, 8, 11, but of course there's an x next to it. So which number gives us 71x? Let's put it equal to it. You can divide by x, giving us just this, add 1, divided by 3, we know it's the 24th term along. Okay, so this is probably when it starts to get difficult, when they're only giving you parts. So we know the 3rd term along is 12, we know the 16th term is 77, we want to find a and d. So let's write a formula. So let's just think about what we can do. So we know if it's the 3rd term, so if we use u3, we know we're going to get 12, and we know that would be a, our starting number, plus 2 lots of the difference, because if u3, then that's going to be 2. If you haven't quite followed that, hang on, I'll just write it down. I didn't mean to do that, hang on. Let's change colour because I hate writing in red. So if you think this is our sequence, sorry, they should be pluses. So if that's a, you could use the example of 4, and if you want the constant difference to be 2, that would be 6, and then that would be 8. So we don't need to do that, so we say a plus d, and then that one is going to be a plus 2d. So our 3rd term, you can see, would be 2d's. Okay, let's keep it going. And I did the same here. So the 16th term, we know it's going to be 77, and that would be 15 differences. We've got 2 equations. We can solve them simultaneously. I'm going to subtract them together to eliminate the a's, giving me this. Divide by 13, d is 5. Let's use this one. You can remember, you're going to check it in the other one, so it doesn't matter which one you use. But if d is 5, 2 d's are going to be worth 10, and therefore a must be 2. So let's check it in the next one. is 77 going to be correct when we put D as 5 and A as 2 in? So 2 plus 75 is 77. We know we've done it right. So when it's like this, you're just manipulating the information, using that formula, told you it's going to come in handy, and solving it simultaneously. Here's the last one. Great question, this. So which values of x would the expression -3, 2x squared, and 13x form the first three terms of an arithmetic series? Wow. So here, there's no way of telling the difference. So that's how we've got to start this off. That's not going to really help us at all in this. So if you think about what I've done here, I've said, if I take this term and I subtract this term, I will get the difference that we're adding on. Because we know that -3 plus the difference is going to give me that. And I can do exactly the same thing. I can do exactly the same thing here. So I know that this term, I'll go back and press the wrong button. That I know that this term, take away this term, is also going to give us that difference. And what I've done, I've written two equations that both equal D, and therefore both of those equations are exactly the same thing. So I can put them equal to each other. You should be able to see that it's a quadratic equation, so everything needs to be on one side. Then you need to factorize it. I've done that quickly because, like I said before, this video is not on factorizing. Then you need to solve it. Okay, so there we have it. They are the values of x that would give this expression. The other way you could have set this up is, I did say it verbally, but that one take away that one equals D, or you could say, well, -3 plus the difference. So to go from -3, we're going to add on D to get this. And that's how I've formed that one. Similarly, I'm going to write 2x squared plus another D is going to give me 13x. And that's a simultaneous equation. If you subtract the D's from both sides, if you subtract the two equations from each other, where's my highlighter? Here it is. So 2x squared minus -3, well, that's the same as that. And 13x minus 2x squared, well, that's the same as that. You're going to end up with this line of working here, no matter how you set the formula up. So that's the hardest thing to get your head around with these. Best of luck. Have fun.